Hey guys, Miss A here. Today is May 12th, 2020. We are God knows how many weeks into quarantine at this point. How are you guys doing? I am holding steady, I guess. It is definitely nice to come to you guys again doing this. I'm sorry my last stream was about 2 weeks ago at this point. I kind of moved apartments in between, so you might notice a change of scenery. Everything's still kind of coming together around here. So, pardon my interruption there, but hopefully, this will get us back on track. I'm hoping to do this every Tuesday and Thursday, sort of between now and the end of the trimester, highlighting a few lessons from CodeHS. So, how is everybody doing today? Like I said, we are God knows how many weeks into quarantine, and I've been thinking about this class, about what it must be like to be a student learning programming right now. And I know a lot of you are kind of suffering from a bit of a lack of motivation. You're like, I don't know how to do this. Why do we have to learn this? Do we have to do this right now in the middle of a pandemic? And in my mind, I honestly can't think of a more important time, maybe not a better time, but a more important time to be learning about computers and about programming and about any of those kinds of things. Because as you can see in New York State, right, they're in talks with Google and Microsoft to reimagine New York, to reimagine our schools. They're going to be making all kinds of decisions that are going to be affecting us all over the place. Right now, how many of us are basically using Zoom, FaceTime, Snapchat, Instagram, YouTube, Netflix, right? This probably sounds like the front page of somebody's iPhone in terms of the apps you have, right? These are the kinds of things that are really keeping us together, keeping us sane, keeping us engaged so that we're all not going a little bit stir crazy up in our lockdowns right now. These are rapidly, right, if it wasn't already apparent how much computers and the internet were kind of taking over our day-to-day life before this all went down, right now, I mean, this is our daily life, is these screens and these streams and the online meetings and online videos and online gaming and online ... right? Everything we're doing is going through these. And so having some kind of understanding about how these work, what the internet is, what at least is just required to get in on these things. And of course, the more you know, the more you can learn about it. And the more you learn about these things, the more interesting that whole picture looks around these tech companies and their relationship to our governments and all of these kinds of things. So, especially as a young person, you're really going to be living in the world that this creates. So, better that you understand this, or at least the more you understand this, the better you know what's going on, the more you understand the arguments that companies like that make, the kind of picture of the world it paints. If nothing else, you just kind of are doing it with a little, it can sometimes seem like a lot of these choices are out of our hands, is maybe what I want to say, but the more you learn about how these things get made, a better job you can do of finding a place for yourself in it, of thinking about its limitations and its benefits in realistic ways, or at the very least, just to kind of have some picture of this big force that's guiding your life, right? At least I'm the kind of person that way. Somebody's making decisions for me, I like to know how they're made. These days, a lot of them are, at least when it comes to the point of actually executing them, making the thing and getting it out to the consumers who end up using it, for better or for worse. That's JavaScript. That's what we're learning. So, it might not seem like it from this point because we're just talking with, Carl the dog, this weird little cartoon dog who's like hopping around a screen and putting down balls and picking them up and all of those good things. How that fits into, all of this, right? The fact that I can stream this to you, that you can get it and receive it, and your computer understands how to show it to you. All of that. It might not seem like this plays a role in it, but this is your entryway into understanding how that world works. So there's plenty of, this quarantine is going to last a long time. I got plenty of time to talk about this. So why don't we get to CodeHS for today? So last time we took a look at lesson 1.3, and in lesson 1.3, we kind of looked at this idea of, well, Carl is this dog. Carl has a lot of limitations. He only knows right out of the box 4 different things that he can do, and that's really limiting. So, like, let's say, what if instead of just wanting him to turn left, we want him to turn right? And that's where functions came in, folks. Functions. Again, we covered this kind of in the last video that I made, but like a function, it is a way to teach Carl a new word. Oh yeah, and by the way, guys, please, I'm just going to be going through the slides like I've done in the last couple of videos, but please do yourself a favor, watch the videos. They are on YouTube. The guys at CodeHS did an absolutely phenomenal job with them, so please, make use of them. I'm just going to try to get through this a little bit quicker than they might. Right, functions, they're chunks of code. They're used to teach Carl or your computer more broadly how to do more things, right? It's about packaging up a few instructions that make a bigger product and just using that as a shorthand. Oh my God, there's my quarantine brain popping up. Is anybody else kind of feeling like that? Like your the whole quarantine is like making your brain kind of fuzzy in weird, different ways. I am definitely feeling like that. I don't know. Let's see how we are in a couple months, huh? So they're absolutely right with this point. Functions allow us to break down our problem into smaller parts and make it easier to understand. And the way that it does that is, right, you can now start splitting up your problem into clear chunks. Or just you can think of them as like creating different kind of parts that can be moved around and that can interact with each other in different ways. And so this is gonna, like, the use of functions is gonna help us find this nice little, middle ground between, say, how a human being would describe a problem and just like a list of very, very, very simple instructions, right? This is going to help us chunk together some of those instructions to be like, okay, these parts do this thing and these parts do these things, rather than just having one very, very, very long line going down the page, of text going down the page. And we'll see quite a bit about that, right? Again, basic kind of setup here, same as in the last video. We give the kind of the function keyword as a sort of, hey, heads up, I'm going to teach you how to do something. And you're right, naming is crucial. I cannot tell you how big of a stickler I am about this when I'm in the classroom, because, like, this is a great example. Build pyramid. What does it do? It builds a pyramid. Great. I don't necessarily know what form that pyramid is going to take. I can imagine, since this would be for Carl the dog, that it might make like some kind of a triangle on screen using the yellow balls. But, I do know that it's some way there's not going to be a pyramid, and then there's going to be a pyramid. Carl is probably going to make it. And so I know that just from looking at the name of this thing, build pyramid. Beautiful. It is what it does. I have a lot of students who will try to, name their things like Young Money or like Dale or, different kinds of simple things. But like the more the name of your function has to do with its actual role in the problem, not just in the program, but in the problem you're addressing, that can go a long way to making your code really make sense to you. Along with the naming, right? The naming is just the first part of using a function, right? Functions always are like a two-part process. You define and you call. You teach, then you ask. So the example that I always use in my classroom is this. So I'll go up to the student who's working on this unit and they're struggling, and I'll say, all right, when I say the word Wurzel, close your laptop screen. Because, right, of course, we're working with laptops in my classroom. And students will do one of two things. The first type of student will immediately, put their hand up to the laptop screen and start trying to close their computer. And I have to stop them and be like, no. I did not actually ask you to do it, right? I just told you, if I say the word Wurzel, here's what I want you to do. I did not actually ask you, I did not actually say Wurzel. I did not give you that command. The second type, they understand that. They are waiting for me to, actually tell them to do this thing. They accept the instruction. They say, okay. And then we just sit there. And, I'm like, well, how are you doing? How's the family? Are your little brother and sister doing okay? Doing any, watched any good TV shows lately? How's NBA 2K? Different kinds of things like that, right? I'll start this weird little conversation. And meanwhile, the students looking at me saying like, what's she talking about? Like, we were supposed to be talking about this program. And that's kind of the point, is that if I define an action for you and then I never actually ask you to use it, we're really just wasting everybody's time. Why did I go through the effort of teaching you this thing if I'm never going to ask you to do it? Why should I, as the programmer, go through that effort? Like, if a person wouldn't like it, the computer's not going to like it, so don't do it. Like, any function that's worth defining is a function that you're going to use. So please define your functions and call your functions, right? Two parts. You got to teach the computer how to do it. You got to ask the computer how to do it. Keep going from there. All right, so here's an example of a function. Let's say I've got Carl and I want him to turn around. Well, hey, looky here. This function is called turn around. I know exactly what it does. It's probably going to turn him around. How does it do that? By making him turn left once, then turn left again. So he's gone from one direction to another direction. I could tell that it was going to do that just from the name, or at least I would expect it. Turn around, he should probably turn around. So again, good naming in practice. Notice that capital A. That's how I can tell that a new word has started. All names must be one word. JavaScript's the kind of what we call the convention, the sort of the style that we tend to use is this one. It's called camel case. Okay? And the reason is that, right, these capital letters that pop up afterwards, they kind of look like the humps of a camel. Cool. All right. So to call the function, so this is defining the function. Here's how you call the function. You just say it. It's like if I were to teach you how to make, I don't know, how to make an entree at a restaurant, right? Let's say you're like starting to work as a chef in the back, and they teach you a recipe, right? And at first that recipe is this long list of instructions. But then eventually, right, somebody should just be able to tell you, hey, we need a shepherd's pie at table 7, right? We need fries at wherever. And you should be able to call up that list of instructions. If you don't remember that list of instructions, right, you should probably have it written down somewhere. You can go and look it up. But the idea is, eventually, once you have learned that recipe, nobody has to tell it to you again to get you to do it. They just have to say, you know, and especially if you've ever worked in the back of a kitchen, you know, like a lot of times they're not saying make this. It's just, you know, fries. That's it. Steak, you know, steak, medium rare. That's it. And calling a function is much the same way. We just use the name. All right, let's take a look at the example here. And so the example here is also using turnaround. So for the turnaround, oopsie doodles, I had actually tried doing this before, but I ran into a snafu and my computer ate the first version of this, which was lovely. So I'd done a little work in there. So let's get back to this. So here's a lovely little program. If we start at the top, well, what is he being asked to do? He is being asked to move. He is being asked to turn around. If we run the program, right, first thing he does is move. Then he turns around. Well, what does turning around entail? First he turns left, then he turns left again, and there's no more commands left, so the program stops. Well, let's rearrange some things. Well, does the function have to be here? What if we put it at the top? Is it going to start with this now? Well, let's see. Well, no. If we notice, it starts on line 6, not line 1 or 2. It starts on line 6. So it's not, this function doesn't do anything until or unless it's called. That's the idea. So first thing he does is move, then he turns around. This is just there to give him more information about how this is done. Okay, and we could do a lot more things with this, right? Like say, what if we wanted him to teach him how to flip, right? Make a whole circle, right? So I would always start by defining it the same way, right? Function, give it a name, let's call it flip. And just to make this even clear, why don't we call this flip once? Because I don't want him to flip multiple times. I just want him to flip once, and if I want him to flip a bunch of times, I will just tell him to flip many times rather than making the function do it. So how should he do this? Well, there's two ways I can do this, right? Either he can turn 4 times. Okay. And we could see that working here. Bam, beautiful. Or we could, if we notice, well, we have this thing called turn around. So instead of turning left 4 times, I could just turn around twice. So now I saved myself a little bit of writing. And this is kind of an illustration of how we can have different scales of things, right? We can have this very basic turn left function. Does one very small thing. We use that to make something a little bit bigger, turn around. And then we can even use that to then make something even bigger. So we have all these different scales, like small to big. So we could even do, say, like, let's make another one. Let's make him touch the ceiling. So I could make a function and call it touch ceiling. Just from the name, what do you think it's going to do? He's probably going to touch the ceiling. In the way that I like to think about this, right, like I said, this should just describe exactly what it's doing. If he's going to touch the ceiling, he should just touch the ceiling. If he's going to come back down, right, he should come back down, right? You could package this all into touch ceiling. But in my mind, it's always much better to kind of break those two apart. Touch the ceiling, come down. Two separate actions, very clear. So let's try this out. So let's think about what he's going to need to do. So let's actually call the function, even though there's nothing in it right now. So, well, I know the first thing I'm going to want him to do is face the ceiling. That's the first thing he has to do to be able to actually get up there. So I reset, I run, and cool, he's like looking up, he's facing the ceiling. Cool. So now he's turned left. So now let's make him move a bunch. I'm not even going to count. Me as a person, yes, I would absolutely count. I always think it's really important to, you know, actually break down your problem and think about what's going on, but you don't have to. And that's what I want to illustrate. The computer will tell you what you need. So I reset and run. And cool, like he's doing what he should be doing. I'm on the right track, but he's not quite there yet. So I'm just going to add another move. And voila, he's touching the ceiling. Okay. So let's check out lesson 5, the start function. So JavaScript as a language loves functions. If you ever do like start to learn a little bit of web programming and start to do JavaScript for web development, like just some regular JavaScript, nothing fancy added onto it. Like basically most of your function or most of your program will just be a bunch of functions that then different things on your web page can use. Like a function that says, say, like if I have a search box, what happens when I click submit? Right, I might have a function that helps the web page know what to do with that. So let's take a look. So the start function is really, I think, here to kind of get you into that habit of thinking of everything in terms of functions, where we really don't want a lot of different pieces like just floating around doing nothing, or sort of floating around not contained in anything. We like code to be contained. So this is what's going to happen. So basically from here on out, all of our programs are going to have a function called start. The start function is going to be the very, very first function that gets called when the page loads. So CodeHS is going to know where we want this to start. And the start function is basically going to be where the main action happens. So in our previous example, let me bring it up. So if we take a look at how we wrote the code here, we had some code inside of functions, but the main action itself was happening outside of them, just there, right? They're not in anything. And the start function is now going to give us a place to put those. So basically the other functions are going to be like helpers. But they're all going to start at the start function. So for instance, right, we want that start function to read like a script, say for a movie. It should describe the actions. This is going to happen first, then this thing, then this thing. And a lot of those will just lead to outside functions. So, for instance, go to store, buy chocolate, come home and celebrate. Wonderful. You can tell they probably wrote this before COVID because this is, nowhere near as easy to do now. But, it's going to the store used to just be, pick up your wallet, go outside, go to the bodega, get some chocolate. Now, there's a lot more steps in there, right? So that go to store function probably had to be rewritten for our current situation, but the action itself is still the same. We're still going to the store. So, right, you can see like the details might change, but the script is more or less going to be similar in terms of like the big actions. Okay, so let's take a look. So we want to build a tower. Okay, and we can see this here. So we have start. Here's all the actions we need to do to make the tower. And we can see, right, it's just going to progressively do that. Then it accesses the turn right function. So, like, we don't need the start function. If I took all this code and stuck it here instead, it's still going to work. It does not like the indentation. So what we can do is I can select all the lines, hit Shift Tab to go back. And if we do this, he does the same thing. Okay? But as our programs get more and more complicated, we're going to want to exercise more and more control over what different parts of our programs can see and interact with. We are not going, like, imagine, say, like a big messy classroom, right? Which all of my students can absolutely picture in their heads. It becomes very hard. Like, if everybody is talking to everybody, it becomes very hard to direct the actions. Or say, like, if everyone is trying to change the same thing at the same time. If anybody's ever tried to do, say, like, tried to write in the same Google Doc as a bunch of other people, it's really hard because everyone keeps changing the same things instead of, like, talking to each other. So functions will eventually help keep that stuff under control. And so this here, like the start function, is really here to get you in this good habit of thinking in terms of like all your code should be in a function. So basically all of this is going to look like this now, right? We're going to have function, function, nothing outside. If it doesn't go in the start if it doesn't go in its own function, it goes in the start function is how you should think. Okay. So good luck with the exercise for this one. Okay. So you're just going to be taking your pancakes, which was, where's the pancakes? Where did those go? Here we go. In lesson 4. And you're going to, so basically start with lesson 4, do the make pancakes exercise and the Mario exercise. Remember with Mario, right, if you think about Mario, right, when he jumps, he goes up and then he comes back down. Unless he gets the weird raccoon tail, like that's when he can fly, but only if he has the raccoon tail. Here, Corel doesn't have that. He jumps up. He needs to come back down. Do not make him float in midair. If he goes up, he comes down. If you have any questions, please leave them in the comments below. Email me. Find me on Google Classroom, on Google Meet, Google everything at this point. If you have any questions for next time, let me know. I'm going to be trying to do this again on Thursday, where we're going to take a look at lessons 6, 7, and 8. Hope to see you there. Bye.